for how to solve if you have a rational exponent. But basically this is going to work like a radical. You want to isolate whatever is being taken to your rational exponent. Rational is just a fancy word for fraction, so you're going to have a fraction exponent in these questions. Now, what I did was in the second step, you would have something to a fraction exponent equal to something, okay? Now, the way you solve this, and this is a little weird, but I'll explain it here in a second. You raise both sides of the equation. My power in my original is n over m. You're going to raise both sides to the reciprocal of whatever that fraction is. So I'm just going to flip that over and be m over n. All right, I know this is just a general case, but whatever your fraction is, you're going to take both sides to the reciprocal power. Now, the reason for that, and that's indicated in this second step here, but when you do a power to a power, right, you multiply the exponents together, and I know this looks weird with the variables. You don't need a common denominator to multiply, and I'm going to get two letters in the same term, so I'm going to write them in alphabetical order. This would just be m times n over m times n, which is 1. So that's going to cancel out that rational exponent when you take both sides to the reciprocal power. Okay, now k value there could be a number, it might be an expression, it's going to kind of depend on the question, but there is another little thing you have to remember for these problems, and that's what's underneath here. Now, in my example problem, I had n written in the place where the numerator of that fraction is. If that's even, then you're going to need a plus minus when you go through and solve the problem. Okay, hang on a second. I'm just going to make up like a tiny example. Let's say I have, I don't know, let's say I have x to the 2/3 power, I'm just making this up, equals 81. Okay. If I'm going to solve this equation, right, I'm just giving you a little tiny example here. What I do to cancel out that 2/3 power is I just take both sides to the reciprocal of that. Okay, and in my original little tiny example there, my numerator was a 2, right? When I take the other side to that reciprocal power, here it's just going to become x. When I take that other side to the reciprocal power, what I am doing, and you can do this on the calculator, but just think about this for a second. Do you remember the bottom out that we did last week? I am introducing there, bottom out, a square root of 81 to the 3rd when I do that. If I introduce a square root into a problem, or a 4th root, I need that plus and minus symbol, because there's actually 2 answers to this question. So this would be 9 to the 3rd is 729. And I'll just show you guys real quick, in the original problem, if you want to check this, I just made this up, of course. If I do 729, oh, and I don't put an extra parenthesis there. If I do 729 to the 2/3 power, that was the original problem, that's 81. But also, if I do negative 729, and I push the right keys, what is wrong with me today? 2/3 power, that is also 81, because if you take that cube root of that negative 729, then you square it, it actually does make it positive. So there's 2 answers to that question. Okay, now, if the numerator of the original is odd, you don't do anything with it. You don't need a plus and minus, because you don't, like if I take a 3rd root, there's no plus and minus. If I take a 5th root, there's no plus and minus, because there's not 2 answers. So if the numerator in your original problem is odd, don't worry about anything. But if the numerator in your original problem, that exponent, is even, you're going to end up taking like a square root or a 4th root, so there's 2 possible answers. So we're just going to practice some equations here, and you can of course use your calculator if you want to. Now, first thing you should do is I would look at the problem and I would look at that exponent. Now, the top of that, actually both the numerator and the denominator are odd here, but specifically the numerator is 3. So when I get rid of that fraction, I'm going to take a cube root is what I'm going to do on the other side. So I do not know plus and minus. So the numerator is odd here. No worries about a plus and minus. We're just going to have one answer to this question. What you do want to do first, though, just get that set of parentheses by itself. Do not distribute anything into parentheses that have an exponent on them ever. Whether that's a fraction or a plain number, don't distribute anything. Get it away, you want to divide. So that would give you x plus 1 to the 3/5 power, and then equals 8. Now, on this question, like I had somebody last period like doing the bottom out and they were foiling. No, I don't want you to foil a bunch of stuff. Don't do that. Just cancel this out right here. We're just going to use the reciprocal power. So 5/3. If I do 3/5 times 5/3, power to a power, multiply my exponents, this literally just becomes x plus 1. That's it. You just have to do the same thing to the other side. So the reciprocal there is the 5/3 power. Now, if you guys want some practice with this and you want to do like the bottom out and practice that, you can. This would be the 3rd root of 8 to the 5th. Or if you want to just grab your calculator, I'm just going to do 8 to the 5/3 power on my calculator real quick. And if anybody needs help doing that, I will be happy to help you with it. If your calculator, if you can't see the exponent, like I can see that's 5/3, if you can't see the exponent, you do need to put parentheses around a fraction exponent. If you can see it in the exponent, like I didn't need parentheses when I typed that in. I could just use my little caret button, 5 divided by 3. As long as the whole thing you can see in the exponent, then you're good. You don't need parentheses. If you can't see your exponent, you might just need to put parentheses around your fraction when you do that. So if you're not getting 32, just try to put parentheses around the 5 and the 3. Okay, sorry. So I get x plus 1 equals 32, and then literally all you got to do is subtract 1 here. So x is going to be, I don't know, I was just about to write 20-something. X is 31. And if you want to plug it back to the original and check, you're totally welcome to do that. Is anybody having a question at the moment? I'm going to scooch this up a little bit. Okay, now, here's what I do whenever I see one of these problems. I immediately just look at it and I'm like, okay, in my original problem, if there's an exponent, this one, the numerator is 4. It's 4/3, so the numerator is even. So I just make myself like a little note, like I need to have a plus and minus because we're going to have 2 answers here. Okay, other than that, just solve it, get that expression that's to that exponent by itself. So get rid of any addition or subtraction first. So I'm just going to add 4 here. So I have 1/2 x to the 4/3 is equal to 128. What would you do next there? The only thing being taken to that exponent is the x. So what would you do next? How do I get rid of the 1/2? Yeah. You can multiply by 2, you can divide by half, whatever your preference is. I'm going to multiply by 2 here real quick because it's a little less writing. All right, so I get x to the 4/3. 128 times 2 is 256. Okay, once you've got that exponent isolated, you're going to get rid of it. Just use the reciprocal. Power to a power. You're going to multiply 4/3 times 3/4. It becomes 12/12, which is 1, and it cancels it out. Whatever I do to that side, though, I got to do to the other side. So I'm going to take both sides here to the 3/4. On the left, you're just going to get x. Okay, now, you have to remember this here. And you don't have to write this. I'm going to write this to the side so you can see what I'm doing. If I do that bottom out we were doing last week, I'm doing the 4th root of 256 to the 3rd. I am introducing that 4th root into the problem to solve it. If you have an even root, you have to have a plus minus symbol. There's 2 answers to this question. And then it's up to you. If you want to try to do it by hand for some extra practice, or if you want to just do 256 to the 3/4 power on your calculator, whatever's easier for you. But this actually has 2 answers. It should be 64 and also negative 64. And here's what I would do. If you want to check, I'm just going to back up one step. I would check it right there, right before I took both sides to the 3/4 power. So if I do 64 to the 4/3, you'll see that's 256. But also, if I do negative 64 to the 4/3, that also is 256. So this one has 2 answers. Both of those work. Because you're doing the 3rd root of negative 64 would be negative 4, but then you're taking it to the 4th power, so that cancels the negative. So that's why you have 2 options for answers to that equation. That only happens if that original numerator was even. So for example, if I look at this next one, I got 4 times x plus 5 to the 2/3 equals 36. First thing I say to myself is, okay, that numerator is a 2, so that means I'm going to end up taking a square root when I use the reciprocal. So I need to make sure that I have 2 answers here because I should have that plus and minus. Just get those, don't distribute that 4 in there. You want to divide. Don't ever distribute if you've got an exponent on your parentheses. You're going to divide. So x plus 5 to the 2/3 equals 9. Okay, now just take both sides to the reciprocal power. When you do that, we're going to take both sides to the 3/2. 2/3 times 3/2 give you 6/6, which is 1. Don't need a common denominator to multiply fractions. So that just cancels that out. You're going to get x plus 5 here. Now on the other side, and you don't have to write this, I'm just trying to get you to think about it. If I do my bottom out, I have introduced here a square root of 9 to the 3rd. So if I have introduced a square root, I better be putting that plus and minus because there's 2 possible answers for this. So square root of 9 is 3. Then I'm going to take that to the 3rd power real quick. So this could be 27 or negative 27, but I'm not done getting x alone. I've got to move the 5. So here's what I would tell you to do. I'm just going to move the 5 real quick. It's positive, so I'm going to subtract it. When I do that, I just write that immediately after the equal sign. So negative 5 plus or minus 27. Okay, if I do negative 5 plus 27, just across the top, negative 5 plus 27 is going to end up being 22. My other option, if I do negative 5 minus 27, that's negative 32. And if you were like, oh, okay, and you want to check, I would come back right here, right before we took both sides to the 3/2 power. So if I just do my x value, which is like one of them's 22, if I do 22 plus 5, that's 27. Take that to the 2/3 power. I'm just checking to make sure that's 9. And if I do negative 32 plus 5, that gives me negative 27. But when I take that to that 2/3 power, that's also going to give me 9. So there's 2 answers there, the 22 and the negative 32. Is anybody having a question? Everything on the front has just numbers on it. We're going to do some variables on the back. Okay. So let me just, before I start, I'm going to ask you a quick question. The 1/4 power is the same as what type of root? I do 1/2 power, same thing as what kind of radical? Square root? Okay, that's all I'm saying. Okay, so 1/2 power is the same thing as a square root. Now, the reason I'm asking you that question, this first problem, there is potential for extraneous solutions on the back here. You're going to have expressions on both sides. So when we get our answer, like that first question is really, if you think about it, that is the square root of 5 minus x. That cannot be equal to a negative number. Okay, so 1/2 power is the same thing as the square root. You're not going to need a plus and minus. The numerator, there's just a 1, which is odd. So I'm going to square both sides here, but I do got to remember this cannot be equal to a negative number because the 1/2 power is the same thing as a square root. So I can't have a square root equal to a negative. Now, all we're going to do, your reciprocal of 1/2, it's not another fraction here. It's actually just 2. So I'm just going to take both sides and square it. So 1/2 and 2, those are reciprocals. Don't worry, we don't need a plus and minus. Don't even worry about it. We're going to square both sides. Now, this is going to result in kind of what we were having in our last lesson, where you don't want to forget that you need to square something. You can't just distribute that exponent. Anytime there's adding or subtracting in those parentheses, we got to do like a FOIL or a box, whichever one you like better. Okay, so if I do my first outside, inside, last, or I just think of it as a double distributive property, I'm going to get x squared plus an x plus another x, and then 1 times 1 is 1. And if I just want to combine my like terms there real quick, you got 2 x's in the middle, so x squared plus 2x plus 1. And then on that other side, I had 5 minus x. Now, this is going to end up being a quadratic. Now, I promise, if it's a quadratic It will be factorable, or you can always use the quadratic formula, but either way you want to set this equal to 0 to do this problem. So I'm going to subtract 5 and subtract x. If you do want to do any factoring, you want to try to keep your squared term positive, because it usually makes it easier to work with. So, oh, fail, I had to add the x. Bad. Okay, sorry. I got x squared plus 3x minus 4. Sorry, that x was negative. I should have added it to the other side. Okay, now, do you guys want factor or quadratic formula? We don't care. Factor is maybe faster for this particular question. So, can you think of two numbers when you multiply them, you get -4. Same two numbers, you add them, you get 3. 4 and -1. Okay, so one of these is a +4, one of these is a -1. Now, my two potential answers then. -4 would set that equal to 0, and +1 would set that equal to 0. Now, what I would do, I'm just going to come back here real quick. Before I squared both sides, I had 1/2 power is the same as a square root. So that 5 minus x cannot be equal to a negative. That expression, x plus 1, I just want a quick check. So if I plug in -4 plus 1, guess what? That's -3. And it really doesn't matter what the number is, but if it makes that side is a square root equal to a negative, that's an extraneous solution. So that -4 will not work. If I plug in 1 plus 1 is 2. So it doesn't matter what the number is, just as long as it's positive, so that's good. So 1 would be our answer there. That -4 would be extraneous. And you don't have to write the extraneous answer. Like if we're doing a test or quiz, you could just write the answer is 1, and then obviously if you have that in your work, you don't need to identify that. Okay, now the one next to this is super tricky. So I do essentially have the parentheses with the rational exponent isolated. It's just I have it on both sides, and those exponents are actually different. So I have 2x plus 1, that's to the 1/2 power. The other side I have 3x plus 4 to the 1/4. Any idea how you would get rid of those exponents?
Would you multiply both by 4?
Yes. Okay, why'd you pick 4?
Because you can make one the square and the other normals.
Exactly. You're basically going to we're going to cancel out both of those exponents at once. So we're really going to take both sides to the 4th power. Now, what's going to happen there with the 1/4, that's just going to go away, right? Those are reciprocals. You want to try and pick the lowest common denominator between the two. So 2 and 4, we're both going to 4. Take both sides to that power. Now, because I'm still going to have an exponent over here. I'm going to have 2x plus 1. What would my exponent be? 2, half of 4, because you're multiplying power to a power. Okay, now, this side's just going to be 3x plus 4. No worries. Now, on the left, though, I do need to do a little bit of a FOIL here. Or box, if you want to draw yourself a box. And so I'm going to get 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is another 2x. 1 times 1 is 1. So altogether, 4x squared plus 4x plus 1. And then the other side there, we had 3x plus 4. Now, I promise you, whatever I give you, it will be factorable. But if you want to use the quadratic formula, you can. If I do either one of those, we got to set this equal to 0. So I'm going to subtract 3x, and I'm going to subtract 4 to do that. So my quadratic here is going to be 4x squared plus x minus 3 equals 0. Okay, now, this one is a little harder to factor because you've got that number in front of the x squared, but you can still do it. Do you guys want to factor, or you want me to use quadratic formula? Here, I tell you what, let me review how to factor this just real quick, because we did you can always use the quadratic formula if you don't want to factor, but let me review this with you just real quick, that little Berry method, because we didn't do that last week. Okay, so you're going to multiply ax squared plus bx plus c. I'm going to multiply a times c, and I'm going to add to the b value. So for this question, because I have a number in front of the x squared, a times c would be 4 times -3, which is -12. And I want to add up to the b value. I just have one x there, so the b value would be 1. Okay, now as you're thinking about that for a second, when you set up your factors, what you do if you're trying to do this Berry method, you just take that first term, which is 4x squared, and you put that at the beginning of each of the factors, but without the squared. So just that, I mean, it works for a normal quadratic to do that as well. It just won't have this step I'm going to do right after that. Now, two numbers multiply to get negative 12, add to get 1. I got to use 4 and negative 3. If I multiply 4 times negative 3, you're going to get negative 12. If I take 4 plus a negative 3, you're going to get 1. Now, you're looking at that going, that does not FOIL back to give me what I had, which is true. That's the little trick to this method. So what you want to do, look inside your factor. If the two terms inside the factor have anything in common, that's not the real factor. So 4x plus 4, those are both divisible by 4. Now, this is a little trick to this. You don't like take a 4 out in front or anything like that. You're just going to rewrite the factor without that in it. So both of those are divisible by 4. The real factor there would be x plus 1. And then you got 4x minus 3. That doesn't have anything in common, so that's the real factor. And if you want to check, I was just spot check, like x times 4x gave you back the 4x squared, and I checked the numbers. 1 times negative 3 is negative 3. So I have the correct factored form there. You could completely FOIL it out if you really wanted to check. But then my two answers, and I do want to check these, I get negative 1 and I get positive 3/4. Those are the two numbers that would set those parentheses equal to 0. If you did quadratic formula, you should get the same two numbers. And then, guys, forgive me, I wrote way too big on this. Okay, you do have to check these just real quick. So on either side here, on the left side, that 1/2 power is a square root. And on the right side, you've got a 1/4 power, that's a 4th root. You cannot get a real solution if you take the square root or the 4th root of a negative number. Okay, so if I plug in, and either side, if it screws up either side, you're done. So if I plug in negative 1, I just cannot have that be negative. So if I do 2 times negative 1, right, that's negative 2 plus 1 is going to be negative 1. So that would make that side of the equation negative. You can't take the square root of a negative. So that negative 1 is going to be an extraneous solution there. So that's not an answer. The 3/4, though, you wouldn't even really have to check any. Everything's being added here. If I plug in a positive number, and I would check both of those because I can't take the square root or the 4th root of a negative. But if I just put in 3/4 there, I'm not doing anything that's going to introduce a negative because they're both, it's 2x plus 1 and 3x plus 4. So as long as that's positive, that'll work. So 3/4 is going to be your answer for that question. The negative 1 doesn't work because it makes you take the square root of a negative on the left-hand side. Is anybody having a question? You got it, yeah. Okay, so yeah, if you plug the negative 1 in here, it would be okay. But you can't do it here because it would make it negative. So yeah, in that scenario, if you have them on both sides, check both sides, both expressions. You don't want them to be equal to it. Really good question. Does anybody else have a question? Okay, now, the very last problem, I'm actually back to, these actually have radicals. These have square roots in them. And there is a question like this on the quiz and the test for this unit. So I wanted to make sure I went over a problem like this. Okay, and it looks kind of garbagey here, right? I've got square root of x minus 9 on one side, and then I have a square root of x, and then a minus 1 not under the square root. Your goal is always going to be to isolate any radical as much as possible, but in that situation, I've just got this negative 1 that's kind of hanging out there, and you could really put it on either side of the equation and still get the same answer. It might be a little bit easier to work with if you put it on the side with this more simple radical. Like this radical just has the square root of x. This is a little more complicated because it has x minus 9. So I would put it on the side that just had just the plain radical x, and I'll show you real quick how to do this. So we're just going to square both sides, right? The left side's super easy. Square root and squared cancel each other out, so just x minus 9. The right side, you're like garbage, but this is actually not too bad. So we're going to FOIL square root of x minus 1 times square root of x minus 1. I promise this looks a little bit complicated, but as you get going through here, it's not bad to do this. So when you FOIL, you can always multiply radicals. They don't have to be like, you're just going to squish them together under the same square root. So if you do square root of x times square root of x, you get square root of x squared, which is going to simplify to just be x. Square root and squared are going to cancel each other out that very first term. Now, I'm going to do square root of x times negative 1, so it would just be a negative square root of x. And I'm literally going to turn around and get the same thing. So another negative 1 times this square root of x, another negative square root of x. And then the last term, negative 1 times negative 1, will turn into positive 1. Now, the only other thing you can do, you do have like radicals here in the middle, negative, and you don't have to write this in, but like a negative 1, put that together. I have negative 2 square roots of x, and then I have this 1. And then, forgive me, I'm just going to bring down the x plus 9, or x minus 9 that was on the other side. Now, here's what's going to happen. Do you guys see I just have a plain x by itself on both sides of the equal sign? So if I would try and get all my like terms on one side, the x here and the x here are actually going to cancel each other out. And I'm going to come up here so I have a little bit more room. I really have negative 9 equals negative 2 roots of x plus 1. The x on either side is going to cancel out. Now, this is just very similar to the radical equations we were solving in our last lesson. So just get rid of any addition or subtraction. So I'm going to move that 1. We're going to end up with negative 10, negative 2 times the square root of x. And then I got to get that radical alone, so I got to get rid of that negative 2. And here I've got a square root of x equal to positive 5, so we're good, that's fine. And what I'm going to do there to get x by itself, this is the square root of x is 5. So to cancel that, I'm going to square both sides, and I'm going to get 25. Now, you should check to make sure you're not taking the square root of a negative number here, which you're not going to be doing, but I would go back to this original problem just real quick, make sure you're not taking a square root of a negative. So like 25 minus 9, that'd be 16, we're good. Square root of 25, that's good. Both sides would be equal to 4 if you simplify that, but your answer there is going to be 25. It looks really rough, but it's actually not too bad once you get going on it. Is anybody having a question? Okay, the homework is super